First of all, I'd like to thank you for your invitation. Obviously, I'm very happy to deliver a talk at this conference. The messages for today are more or less like this. I'll try to convince you first that abductive reasoning is a compound one, which is slightly against the usual way of conceiving what abductive reasoning is. But although it's probably the most important message, still it's a kind of side effect of the whole talk, because it will be concerned mostly with some methodological issues in research on form or structure of human reasoning. Because what I'm trying to show you mostly is that if we try to perform any sensible kinds of research on actual reasoning processes, then we simply need to go for a very peculiar, very specific kind of methodology, which maybe not mainstream, but historically prevalent paradigm in psychology or cognitive science and, of reasoning usually used to ignore. So the second message is that in order to perform sensible research on reasoning, in this case abductive reasoning, you need proper tools for harvesting empirical data. And the first point is that there is not many such proper tools. The second point is that we designed two which work, in fact, pretty well. The third and the fourth point is that abductive reasoning can be modeled. And I'm going to bravely use the term model here for a couple of times, although this term can be understood, yeah, in many different ways, I think. I'll show you two such, let's say, models. The first one, which stemmed from modeling, let's say, convergent case, a tool in which our subjects were supposed to perform a search for the abductive hypothesis. In this type of tasks, there is the proper solution to the abductive problem. And the second, which is probably more interesting, the divergent case, in which there is no proper or correct solution, in which just we try to evaluate the style or strategy by which our subjects try to account for the problem. These two terms, convergent and divergent cases, shouldn't be understood in terms of convergent and divergent thinking, because basically nobody knows what does it mean. It's simply, I use these terms just to indicate that in the first convergent case, the solutions should converge on some particular type of information. And in the divergent case, it's slightly different. And another side effect, or side message, let's say, would be that's kind of follow-up of Pavel's yesterday's talk, that questions are mere wheels of problem solving. So the agenda is more or less like this. I shall start with some very general remarks concerning setting the stage for this kind of reasoning. Then I'll turn to the framework, abduction as compound form of reasoning, and then the tools. So setting the stage. First of all, if we are trying to perform any kind of research on real human reasoning processes, we can address basically three types of issues, or if you prefer, we can do this from three different perspectives. The first one, and again, historically prevalent one, let's say, was this normative perspective, in which we are searching for something like normative rules according to which reasoning should be performed. One trouble is, of course, that in order to make sense of that, you need to have suitably defined normative yardstick. You need some idealized concept of what does it mean for a reasoning to be normatively correct. And the trouble is that the usual suspect, that is deductive reasoning, doesn't work very well here. On the other hand, you can go for description. You can go just for establishing what people really do and try to describe these activities and to build from this or on top of this some kind of theory. But there is also this third perspective, and this is the perspective I'm interested in, this prescriptive perspective, which basically stems from the fact, from a simple observation that usually our reasoning falls short of normative standards, whatever these norms are. But the reason for that is mostly concerned with our computational limitations. And if we try to take this into account, then we can build some kind of models of what people do, how people do solve certain kinds of problems, which are not that abstract as the normative ones, and not that, I would say, idiographic as descriptive ones. Something from which we can learn about some regularities in problem solving. So, if we try to ask the question, what then can we achieve with such an approach? Well, basically we need to locate ourselves somewhere along this line from Panglossian's overly optimistic approach to what can we do with normative approach, all the way down to eliminativists who claim that, well, we usually don't reason in real life context. Usually we just solve problems, and problem solving typically doesn't amount to reasoning. I would position myself probably somewhere in the middle between the meliorist and apologist, something like that. And please notice that this third position, the meliorist, which claims that actual human reasoning falls short even of prescriptive standards because, well, our computational limitations are serious and are to be taken seriously. It's kind of optimistic from the point of view of logic teacher because it's usually associated with the claim that there is a lot of space for improvement by a proper logical education. All this obviously can be described in terms of this practical or cognitive, if you prefer, turn in logic, which we witnessed for last like 20 or 20-something years, which, well, it's not that revolutionary if you think about what Aristotle already wrote in the first Analytics, because it's more or less coming back to the initial idea of what logic is or should be about. Although this is now expressed in slightly more modern terms, like this new task for logic of systematically keeping track of changing representations of information. If you look into the quite early ideas on syllogistic reasoning, for example, this is something that you can read out from Aristotle as well. And this is something that was kind of important from a point of view of trying to build a formal model of a structure of this or that kind of reasoning, and it is the claim that, well, obviously, you can do logical research without paying much attention to what people really do, how do they reason, without paying much attention to whether your formal systems could be applied to some areas of reality, let's say, outside the Platonic world or not. It's perfectly justified, but, and this is the claim, this is the basic claim of this new psychologism, or cognitivism if you prefer, but it's much more fun and it's much more interesting if your logical systems do have some connections, do relate somehow to outside reality. So that's the stage. Now the framework. Abductive reasoning is more or less, or could be understood more or less, as a reasoning by which we try to make sense of some puzzling, surprising phenomena. This phenomena could be basically everything, and this is not a very good definition of what abduction is, but it captures nicely the function of abductive reasoning. Probably the best known formulation of or account on the structure of abductive reasoning is this one by Peirce, which, under, let's say, a kind of credulous account or interpretation, could be reduced to more or less affirming the consequent schema. Yes, something is observed. If something else were true, then this observation wouldn't be surprising at all. So there is a reason to suspect that this potential cause of our observed phenomenon is true. This formulation obviously is not that neutral with respect to the function of abductive reasoning, but we'll go to that in a moment. I just mentioned that in the background you have a picture of translation of Analytica Priora done by Giulio Pace. It's late 16th century edition, in which for the first time the term abduction was used here at the very beginning of the 25th chapter of Analytica Priora. After that, typical translation of apagoge here is reductive reasoning. Giulio Pace used the term abduction for the first time. So, abductive reasoning is a form of cognitive activity. That's a kind of broad account I try to defend in a moment. Cognitive activity by which we make sense of something that is surprising, ambiguous, puzzling. By abduction, we basically fill the gaps in our beliefs. That's the fundamental role of abductive reasoning in our spectrum of our cognitive activities. And obviously, if we take abduction to be that broad kind of, well, not only reasoning, but general cognitive activity, then you can find examples of it in lots and lots of different areas. It's not the case that everything is abduction, but seems that this is the kind of information processing, not only reasoning, but in general information processing, which is much more ubiquitous than we used to think about using more traditional, let's say, classifications of reasoning, which involve deduction, induction, and probably something in between. In Peirce, we have a couple of models of or accounts for abductive reasoning, a couple of accounts on what abduction is. In particular, we have one couple of such accounts. The one which is expressed in terms of permutations of classical categorical sentences, in which deduction, induction, and abduction are expressed in terms of differently ordered syllogisms, let's say. But a little bit more interesting is the second one, usually called an inferential account, which is typically depicted in terms of this, well, let's say, a circle of knowledge, in which the role of abduction is to introduce new ideas. The role of abduction is to enable creativity or some kind of novelty at all in human cognition. By abduction, we make sense of surprising data. We make sense by establishing hypotheses, explanatory or not, depends. Then we test hypotheses by deduction. We formulate predictions, and predictions become, by induction, new data, and the world goes round and round and round. So, but this still doesn't explain what is abduction. It's still not a definition of what this kind of reasoning is. The trouble with this kind of reasoning, as opposed to, for example, deductive reasoning, is that in deductive reasoning we have a kind of simple means of defining, of finding a criteria for a reasoning to be deductive one. It's just logical entailment. If you're able to find some model in which your reasoning can be grounded in terms of logical entailment, then you basically have a deductive reasoning at hand. In case of abduction, the trouble is that we can account for this schema in a couple of different terms. We can try to define abductive reasoning in terms of its structure. That would be nice, but apparently it's not enough, because affirming the consequent need not to be abductive reasoning. We can account for abductive reasoning in terms of its function. That seems at least much better, because if we think about how to explain what abductive reasoning amounts to, well, we do this in terms of function. We do this in terms of the purpose which abductive reasoning serves, this filling the gaps in our knowledge. Of course, it would be really nice to have an account on abduction in terms of relation between premises and conclusion, like in deduction. But that's probably not a very feasible way of proceeding. The other trouble is that abduction is a kind of information processing activity. Let's say a reasoning. Great. But existing research on abductive reasoning and accounts on what abduction is, not how it is performed, but what it is, usually are slightly limited in that they focus on the abductive product, on the hypothesis which is generated by some processes, whatever. If we say if we go for a conclusion like this, then we need not to be interested in, say, the ways in which our A is generated. Not really. We could be just interested in the properties of A. We could be interested in the properties of that hypothesis, in the properties of a gap filler, whether the piece of information which fills a gap in our belief is, say, coherent with other beliefs or something like that. And we need not to ask otherwise interesting question about by means of what kind of processes this information was generated. The third point, kind of difficult, and this is the really important one, is whether we are interested in modeling abduction as just generation of hypotheses, generation of these gap fillers, or we are interested in generation of hypotheses which have certain characteristics, like which are better than the other ones, for example. If you look at this schema, again, there is nothing that forces us to consider evaluation of abductive hypothesis as an inherent part of the reasoning. We could just go and generate hypotheses like crazy, and then after the, well, whatever, generation of a satisfactorily large set of them, we can try to be picky and evaluate which is better and which is not. But it's not how abductive reasoning usually works. Because if we perform abductive reasoning in real-life context, we are not just crazy generators. We try to be economic. We try to devise hypotheses which are maybe not globally, but at least locally optimal. So evaluation of hypotheses is somehow intertwined with the process of generation of abductive hypothesis. And finally, that's a minor point, but still, there is an ongoing discussion on whether these hypotheses need to be explanatory or not. Whether this making sense of puzzling phenomena, again, back to Peirce, should be such that A is an explanation for C to happen or not. Different answers to all these questions lead to different accounts on what abduction is, to different models of abductive reasoning. Still, there is no answer to the question, what is abductive reasoning? Okay. In Peirce, we can find or reconstruct a couple of, four in fact, theses which characterize abductive reasoning, and my focus here is on two of them. The first one is autonomy thesis, which claims that abduction is something peculiar, something different than other kinds of reasoning. Right. That's probably good, because otherwise, why cares for abduction? So there is a lot of effort to identify abduction as this irreducible kind of reasoning, as something that is totally different than deductive, inductive, or whatever other kind of reasoning. And as a result, for example, inference to the best explanation, which once looked like a paradigmatic example of what abductive reasoning is, more often than not now is rejected as case of abductive reasoning because it's too inductive, so can't be. It's not that different from induction to deserve to be abductive reasoning. On the other hand, we have the thesis of purpose, which claims more or less that this generation and evaluation of hypotheses in abductive reasoning are rather hard to separate. That abductive reasoning is, the purpose of abductive reasoning is not only to produce hypotheses, but also to select among them. So my claim is that with this thesis, we go beyond this Peircean circle of knowledge, and that abduction becomes, in fact, a compound form of reasoning, which means that this is a type of activity which subsumes or involves, if you prefer, other kinds of reasoning. Deduction, for example, in particular, in this evaluation phase. If you think about testing of hypotheses, it's quite obvious that from time to time we use, in order to test our hypothesis, deductive reasoning. And I can see no point in claiming that there should be no overlap between abductive, deductive, and inductive reasoning. Mostly because when people perform reasoning, which by all means seem to be abductive, they do reason deductively, inductively, by analogy, and so on, so on, so on. But obviously, besides this testing part, we have also this generation part, generation of hypotheses. So there is still an issue by which kind of reasoning, if at all by reasoning, hypotheses are generated. And well, the trouble is that I don't have a good solution to that at the moment. Certainly there must be something. The question whether these processes can be separated from all the others, whether this generation phase can be separated from evaluation phase, is a different problem. But certainly there must be some processes by which hypotheses are generated, and they are probably some forms of reductive reasoning more or less similar in structure to exactly affirming the consequent. In case of abduction, its basic characteristic, as basic in fact as this truth preservation in case of deduction, is that by abduction we fill the gaps in our beliefs. And usually we are kind of picky in choosing these fillers. We are not satisfied in filling the gaps in our beliefs by any kind of garbage we can generate. We are interested in, well, quality information stuff. Although, obviously, a judgment of what is a quality information could differ from individual to individual. Still, under this account, you can't claim sensibly that evaluation of hypothesis is merely of practical importance, because there is nothing mere in that. That's a fundamental feature of abductive reasoning, its practicality, say. And also, you can extend this account on abductive reasoning to cover other types of cognitive activities, and you can claim that abductive reasoning is in fact just a case of abduction, and that more or less any kind of interpretative activity can be understood or construed in terms of abductive mechanism, of this abductive making sense mechanisms. So there is this one rather important methodological consequence when we started to look for the proper methodology for empirical research on abductive reasoning. It became kind of obvious that we can't go for like paper and pencil questionnaires, because, well, we need, in order to build a sensible account on this kind of reasoning, we need access to subjects' reasoning processes. We need somehow to learn what the subjects are doing while trying to solve abductive problems. And you can do this in a couple of different ways. I'll show you two of the possibilities in a moment. But that's one important point. The second is that, well, obviously, the models we are trying to address here, we are trying to build, are not supposed to be like human artificially built twin sisters of real abductive processes. Well, that would be nice, of course, to have something that is psychologically adequate to up to the point that we could claim that this is exactly what people do. But well, in this case of research, in case of this research, you need to be humble a little bit. So what you do, you start with approximation, and you need to scale your results, because as basically in case of any research in say cognitive psychology, you can to some extent only hope that your laboratory results could be translated into what Pavel yesterday called the wild. Yeah? Although we are trying to gather evidence exactly from this source. And the goal is here to have a formal model of a structure of abductive reasoning. In particular, such in terms of which differences in performing abduction can be addressed, up to the level of individual differences, even, because it seems to me that this interpretational activity, this gap-filling activity in our beliefs is so fundamental to our everyday cognitive activities that we can find at least a couple of reasonable examples of psychological constructs which should be related to our abductive abilities. If you think, for example, of need for cognitive closure, if you read what need for cognitive closure is supposed to be, then, well, the impression that this is something of abductive character is kind of hard to be avoided. And of course, it's always good in this kind of research to have in mind this distinction of reasoning to an interpretation and reasoning from an interpretation, because more often than not in such kind of research it happens that what the experimenter had in mind creating a task for a subject to be solved, it's completely different from what the subject is really doing. So you need to be careful in that respect too. So the tools. We tried to address all these issues with two tools with reasonable psychometric properties, let's say. In one case, we started the approximation, let's say, with a rather simple case of tasks in which the subject's goal is to make sense of something that is surprising, let's say, but in which the subject is supposed to find the proper solution, the proper explanation of the happenings. And one step further, that was mind maze, and one step further find out is a slightly more complicated tool in which the subjects have more freedom, let's say. We got richer data, but they are slightly harder to be modeled. Why to create a new tool for this kind of research at all? Because, well, there are none, or at least none which are acceptable for our purposes. There is a couple of empirical research on abductive reasoning, but in highly specialized contexts, and they mostly focus on the product, not the process. In case of these two tools, Mind Maze and Find Out, we went for a context in which there is no nomological diagnosis and no forensic context, because in our pilot research it turned out that both these kind of contexts they invoke very peculiar attitudes in subjects. And if we want to have data that resemble natural language context, natural language data, there shouldn't be like that, because it's slightly different state of mind, let's say, needed in order to solve this kind of puzzle. The guidelines were as follows. We wanted to catch abduction as a compound form of reasoning. We wanted to evaluate both process and product. And we wanted to provide these both types of analysis of performance of our subjects. And also, we wanted to create something that would be a proper tool. So we wanted something that will be administered as a decent method, let's say, but on the other hand, that will compromise between this and real-life conditions. So we started with Mind Maze. Mind Maze is, well, a kind of party game in which the idea is that you are presented with a puzzling story and your task is to explain what happened. If you know, for example, black stories, this is more or less like this, although there is nothing black in that. No dying, no corpses, no murders, basically no forensic context. And the authors of the game claim that all the stories put there are stories, are real life stories. Sometimes it's hard to believe, but well, okay. We needed a decent level of simplification, of course, to make the data well approachable, let's say. So we decided to go for a tool in which the subject solves the problem by asking questions to the external source of information, to the game master, but these questions are limited to yes/no questions only. In case of Mind Maze, is in fact slightly more complicated because there are two more possible answers allowed, not important and I don't know as well. And we recorded the sessions and then transcribed them, and we get where it is here. We get something like 39 game logs. At the moment, all the data are available as parts of erotic reasoning corpus. Here you have a toy example of Mind Maze. That's in fact an example from instruction to the game, but this gives you an idea what this game consists in. Yeah, there is a story. The player is supposed to ask simple yes/no questions. The game master is supposed to deliver answers, and our player is supposed at some point to arrive at the solution, because each story here has the proper solution. Of course, this story is rather simple, and we had to go for a couple of modifications of the original rules in order to make them more precise, say, to produce something that will be standardized. First of all, because this was our point of interest, the players are encouraged to think aloud. So this is a strong verbal protocol context. Of course, there is some interference between thinking aloud and thinking, but well, that's the price. And the players are asked to provide justifications for questions. This was the reason for that modification was that we wanted to include game logs from this research into the corpus, and we wanted to be able to identify the reasoning processes by which posing questions was justified, just to check whether they are along the lines of our normative inferential erotic logic model or not. And also probably the sixth and seventh point are important here, especially the seventh one. The game master is allowed to use critical suggestions because, well, in this kind of research, you can't leave your subjects with unsolved mystery. You can't leave your subjects with the feeling that, oh boy, I'm so stupid, I can't solve the puzzle, even if they can't. So you need somehow to walk them to the proper solution. Well, an exemplary task of Mind Maze is like this. This is a real example. If you look at the story, it's quite evident that there are two crucial pieces of information that should be identified in order to solve the puzzle. The first one is the profession. The second one is the answer to the question how. Yeah? And the proper solution, the solution consists in identifying these two issues. Well, the subjects usually go through a number of topics, and we understand the notion of topic here in terms of, or along the lines proposed by Van Couperveld, in terms of this aboutness of sets of utterances. And now The point is that we would like to have a model for that. Well, let's first go for something that is even simpler than the mind maze setup, the 20 questions game. The idea is that the game master, say, identifies a set of objects, and the task of a player is to ask consecutive yes/no questions, at most 20 of them, in order to establish what the game master has in mind. If you look at this gameplay, two things should be obvious. The first one is that this is a set theoretical play. You start with sets of objects, and you do something with these sets. You start with the very general, let's say, topic or set of objects, something, let's say, and then you go by these questions. Is it an animal? Well, yes, it is an animal. So your set of objects of interest is somehow narrowed down or funneled, as we start to say in a moment. And so on, so on, so on. Is it a mammal? Is it a rodent? Is it a rat? Well, no. So if not a rat, then maybe something else. So on, so on, so on. So these are basically kind of simple operations, set theoretical operations, which aim is to identify the objects the game master has in mind. The trouble is that if you think about tasks like the traveler, well, it's not that evident that what you are supposed to do can be described in set theoretical terms, because there are no sets of objects. Or are they? Well, are they? There are, but kind of peculiar. We went for modeling this kind of solutions to this kind of tasks in terms of situational semantics. You can choose basically any kind of situational semantics you want. This is a very simple model, very simple set theoretical model, but you can go for something more refined, like inquisitive semantics, like first order situational semantics, or truth makers, whatever. It works, basically. You need some concept of relevance, because not every question is relevant in every context. That's why here is this partial function defined. And you have these two operations. The first one is, in fact, family of operations. The second one is an operation. Sifting and funneling. If you look at this again, this example, what is happening here? Let's suppose that this omega is a general topic of, well, being something, whatever. The question, is it an animal, what you have in mind, in a sense narrows down or funnels the topic, whatever, something. The question, after the affirmative answer is given, the question, is it a mammal, funnels the topic of being an animal even further, and so on, so on, so on. And if you look, for example, at questions Q6 and Q7, that is it a guinea pig, is it a hamster? Can you believe that this is a serious conference? I'm talking about guinea pigs and hamsters. Is it a guinea pig, is it a hamster? Well, what they do, they kind of sift the topic of being a pet. Yes, they provide maybe not a logical division, although in this case this could be viewed as attempt at logical division of a set of a topic. So we have these two operations. Sifting, which can be defined in a couple of different versions. The simplest and strongest, I would say, is this disjoint sifting, in which we aim at logical division of a certain topic. The general idea is that if we try to sift something, then some kind of information must be left out, must be sifted out. And funneling, which, well, basically is a very apt name for the operation it relates to, because what we do by funneling, we exactly funnel the set of, well, situations. The trouble is, of course, that the very concept of situation is understood here as a primitive notion. So we start with the classics, like Keith Devlin, for example, claimed that situations are just that, situations, and we are not looking into the problem further. But this can be done if you go for some slightly more refined version of semantics. There are some shortcomings of this setup, because this is a kind of, well, first approximation of the problem. This list is not exhaustive, but still it indicates the most important ones. The very first one being that the solution is of convergent kind. That is, there is the proper solution. And it's not how we really usually perform abductive reasoning. Because in everyday context, if we solve abductive problems, if we reason abductively, then usually we are trying to come up with some solution, some hypothesis, but we don't have a normative yardstick or external source of information which could be, first, reliable, second, which could tell us that, yes, this is the proper solution of your problem. Life would be simpler, but not always is the case. The other important problems are, for example, this, that there is rather insufficient scope of standardization of the whole process. So let's go for something more complicated, for something that would allow for more divergent solutions to be generated and evaluated, and for something that would be performed in a more standardized environment. And this is the find out. This is the second approximation of a task by which we want to assess, to model abductive reasoning and assess, hopefully, abductive competences. In find out, the general idea is that the subject is playing a role of an investigator for a local media outlet. It's still not that forensic, let's say. But there is a certain level of role play involved in that task. The investigator is seeking for an explanation of what has happened in presented situation. The situation is one and only. In case of Mind Maze, we have a couple of 12, in fact, different stories. Here we have only one. All the subjects solve the same mystery, and they do this in laboratory setting. There is no verbal reports, but all the reports or the subjects doing are written down. Again, this could be questionable because definitely we lose something. We don't have access to the hot thoughts of our subjects, only to some kind of artifacts. But still, that's the price. The task is like this. It's a slightly more elaborated task than in case of Mind Maze, and there is more crucial information that should be, or crucial points that should be explained or accounted for than in Mind Maze task, where there were always either just one or two key pieces of information. Here, in this story, there is at least 5 such pieces of information which should be accounted for in order to the explanation or hypothesis, abductive hypothesis, to be in a sense complete. That's one element, by the way, that can be assessed. Basically, the idea is that we have a description of a situation in which the police stopped a car with a celebrity inside, a local celebrity inside, and there was some smell of a wine, and well, it's not good when a police smells a wine in your car while you're driving. So there were breathalyzer tests, and there were results of the test, and there was some talking, and the driver drove off, and the police also drove off, but in a different direction. And the question is, what happened? There is a couple of these key pieces of information that need to be accounted for here in order to explanation to be complete. And this whole setup is, well, it is kind of tiresome, both for the experimenter and for the subjects, because the single session lasts for like an hour, 65 minutes in fact, and consists of 3 stages. And in these 3 stages, the subjects are writing down all what is, from their perspective, needed in order to solve the puzzle in these 3 forms: scratchpad, notepad, report. In case of scratchpad, this is exactly this, just scratchpad, just all the crazy ideas you can have. Notepad is, well, you need to start to elaborate the hypotheses which look more promising than the others. And final report is something that should be delivered to the local media as the breaking news, as a breaking news report. The first stage, the problem is presented. The subject is asked to write all the crazy explanations that come to mind. The second stage, the subject is allowed to start asking questions to external sources of information. Again, yes/no questions only, because we need to make the whole process approachable from a computational point of view, let's say. But one basic difference between this and mind maze is that here we allow for yes/no questions only, really, only these 2 answers, yes or no. So the whole situation, let's say, needs to be complete, because the subjects ask all the kinds of crazy questions or unrelated questions, like what was the color of the car? And we need to have answer to that. The car was red, by the way, and it was Opel Corsa. A new one, because it's a celebrity, but still. So this is the second stage, and the third stage, the final report for the editor-in-chief of the breaking news piece. Yeah. That's the idea. So what's the difference between the 2? Convergent and divergent case. This solution and a solution. First of all, the difference is in that we are not going to limit the imagination of the subjects here. Although in our pilot study, most of them solved this puzzle in a way, well, it is intended to be solved, let's say, because there is a solution, kind of prescribed solution to the story. But there are some who go for something, well, less standard, let's say, and we need to be prepared for all these possible crazy questions. We have this game-like setup. We have the standardization. We have everything what is needed. What we need is some way of analyzing data. The whole idea of this kind of, in fact, exploratory research is like in mind maze. We approach the problem without assumed model in mind, without assumed model that people should do this or that in order to solve the puzzle. We try to extract a model from this data. We try to extract from the data, from the descriptions of or reports of our subjects' doings, we are trying to extract some regularities which not necessarily will be adequate descriptions of what they do. It's not that kind of model we have in mind. What we are interested in is some computational, some formal tools by which this prescriptive perspective can be addressed in solving this kind of tasks. So, subjects' performance varies, of course, in a number of ways. At every stage, we have different levels of elaboration of solution. There is, in fact, a list of possible variables that can be extracted from this kind of data. We have different attitudes, let's say, in building the solution. which, by the way, nicely coincides with some additional variables, some additional psychological constructs for which we tested also our subjects. There are, of course, some hurdles, troubles, challenges, and puzzles, but no. At the moment, what I'm presenting is are just very beginner's guide, let's say, to analyzing this kind of data, and it seems that. As in case of mind maze, we went for something that is set theoretical. In case of find out, what is most promising way of analyzing the data will be delivered by the graph theory. Because here it's not about identifying this and not any other piece of information. There is no the proper solution, but here the problem is for subjects to cover the space of certain space of information that need to be addressed. And these informations stem somehow from what is told in the story, from the information they gather from external sources of data. And graph theory in this case seems to be very helpful. So, all this was, in fact, a methodological rant on how to do research on models for reasoning processes. In case of abduction, one specificity is that there is no normative model for this kind of reasoning. So there is nothing you can relate to, as in case of deductive reasoning, for example, in order to say, yes, this reasoning is good and this is, well, not that much of a well-established cognitive process. In order to elaborate theory for such a reasoning, you need, in fact, empirical data, because what you do in order to define your correctness is more or less you are trying to extract this concept, or to triangulate, in fact, this correctness between your initial assumptions and what people really do. And in fact, whatever you are trying to research on in such a context, you need tools with good psychometric properties. Of course, there is a couple of other things that can be addressed in this context, from something that is, well, more like descriptive stuff, this possible correlations between different constructs and, well, variables that we extract from our research, and also this more, let's say, structural level of questions, whether some other underlying formalism would perform any better than what we already done. So, as a final message, probably this quotation from Stenning and van Lambalgen would be a proper one. It seems that you can approach the problem of how people solve certain kinds of tasks with lots of presuppositions or biases in mind, but it's always good to listen to your subjects, because more often than not, it happens that what you have in mind and what your subjects could do are two slightly different things. Thank you very much.
Thank you very much for the talk, and now it's time for a discussion. So, are there any questions regarding to abduction and how to catch it? Okay, so we've got these games. We got two presenting, basically, roughly. Are you trying also to involve some different games right now, or just these two?
Just these two. Thank you very much. We have, at the moment, we have, from Mind Maze, well, in case of mind maze, we were able to devise two formal accounts for representing solutions. One in terms of inferential arithmetic logic, but employing slightly weaker relations than Pavel was talking about yesterday, not regular arithmetic implication, but a weak one, in which we go for something that is called partial cognitive usefulness. The idea is that not every answer to a question which is a conclusion needs to be useful in order for a question to be implied, roughly. But it was not very convincing model, so we went for this theoretical one, and we still have lots of data, which well, some of them currently are subjects, as far as I know, of ongoing MA projects. In case of FindOut, the trouble is that we gathered data from the pilot research, and at the moment I have rather sensible and well-behaving, let's say, formalism for modeling the differences between final solutions our subjects provided. So I can evaluate the reports, and I can well do some kind of cross-evaluation. But there is much more in that, in this data, because we have like 60 minutes of intense intellectual work documented in the logs. And I don't think we'll try to go for any other tool before we'll be satisfied with models of what is happening there.
Okay. Are there any other questions? Yeah.
Yeah. I start by apologizing for entering just a little bit late, so it may be that what I want to ask is something that you said at the very beginning. That it's a compound process. Started out with saying that, and I was wondering if you could elaborate a little bit explicitly what precisely you mean by that, and maybe relate it to the things that we talked about, that we discussed yesterday, with these levels of explanation in the explanation of any cognitive phenomenon. So the chair was asking anybody any suggestions about abduction and what it is, suggesting a singular, simplex kind of phenomena, but what is the relationship between your notion of compound, it being a compound phenomenon, and the levels distinction that we tried to address also yesterday?
Well, I'm not sure if there is any straightforward connection, let's say, but let's say this. In case of this simpler, this first approximation, this mind maze tasks, what we have are two different computational accounts, two different formal models of our subject's doings. And it seems to me that this can be interpreted as a case for what we've been talking about yesterday, that it may happen that you have basically the same algorithm expressed in terms of two different computational models. Although this will be with a proviso that in case of these three levels of MAR, it seems to me that one peculiar virtue of this well, theory, model, whatever, is that it can be applied at many different levels. That is, that it's not only the case that you have this computational, algorithmic, and implementation level, and implementation is always fixed because it's, in case of reasoning processes, because it's always neural, then you have some algorithm, whatever, and computation, whatever also, but different. It seems to me that, in fact, when you consider this reasoning phenomena at any kind of level, like for example, you try to answer what our subjects do while typing solutions for find-out tasks. It seems to me that you can address this question exactly in terms of this three-level hypothesis, although the implementation won't be obviously neural in this case, but will be something different. But still, there are these levels of how something is computed, what is computed, and the means in which this is implemented. That would be the first thing. The second, in case of mind maze, it's not that straightforward, and in case of find out, I don't have at the moment a well elaborated solution. But the trouble is that in case of this first approximation, the simpler task, what Stenning and Van Lambalgen call reasoning to an interpretation is kind of implicit. In case of find out is explicit, but I don't have a formal account on that for a moment. In case of mind maze, it is implicit because the subjects first need to construe somehow the task. That is, they need to identify what kind of information I need in order to solve the puzzle. This is the first stage of this abduction being compound reasoning, because they need to somehow elaborate this problem, and this is well, slightly obscure, but still an attempt to address this implicit phase. There is some cognitive target T. There are some two pieces of information which address this issue, and there is hypothesized, unfortunately, in the line number 4, compound numerical question, which basically asks about which pieces of information are such that they will be satisfactory in solving the solution. With evaluation of abductive hypothesis, we definitely go for something that involves other types of reasoning. But again, back to the question. It seems to me that you can make kind of different uses of this three-level hypothesis, and of course the claim that there is a function that can be computed by different algorithms, yeah, definitely. But you can interpret this kind of tasks also in such a way that the very same algorithm can be described, or realizations of it can be described in terms of two different formalisms, and in this sense, these computational levels are different while rooted in the very same algorithmic level. That's, I would say, would be the relation.
Okay, point of clarification that came up, a question of clarification that comes up during your response. In the mind maze and find out tasks, would you characterize those tasks, so the nature of the puzzles to be solved, as coinciding with being an issue of abductive reasoning? That's how it is constructed, or would you say that abductive reasoning is only a necessary component of the cognitive puzzle, of the task that is required, that is to be performed in order to solve the puzzle? Which of the two?
I would say probably that both, because this could be correct because the solution to the task like this involves generation not of a single one, but of at least a couple of different hypotheses. So there is multiple abductions, and the goal itself is abductive as well.
Probably also inductions and deductions.
Absolutely.
Yeah, exactly.
Yes, but
that is to say, deductions and inductions in the logical sense of those words.
Yeah, why not? And under my account on this problem, it is that abduction simply subsumes deduction and induction from time to time, because you need deductive reasoning in order to test abductive hypotheses. And you are not satisfied, usually you are not satisfied with just generating a number of different hypotheses. You want to establish which one is the best among the possibilities. And in order to do that, you can't do this by creative processes. You need deduction, induction, and probably some other process as well.
But with this response, I am tempted to invoke my cognitive semantics background, namely that you are treating metonymically related but still distinct senses of the word abduction. Any noun, any verb, basically any content word in a natural language lexicon has a lot of metonymic polyphony structure to them. And in scientific analysis, I mean, that was precisely the background of my previous question. We have to be very careful not to mix one sense with another, even though they are metonymically connected. Do you get what I'm...
Yeah, but I still don't think that this is... well, this is a problem, but probably in a slightly different sense. That is, let's suppose for a moment that we have a well-established concept of deductive reasoning, which is the fact. Let's suppose that we do have a well-established concept of inductive reasoning. Great. And numerical induction. And now let's suppose that we want to establish a well-behaving concept of abductive reasoning. We need to address this issue at some level of whatever, abstraction, what you prefer, yes? So certainly you can use the term abductive reasoning or abduction at many different levels. But what I'm trying to do here is to address this level, this ontological shelf, let's say, on which these other notions like deduction, induction, and so on lies. That would be the task. And from that perspective, I claim that abduction is abductive reasoning is a compound form of reasoning. Unfortunately, and in this you are completely right, the uses of the very term are so diverse that I probably can't claim that this account captures all of them. No, not really. And in particular, I have serious doubts whether this is a good way of addressing the issue of what abduction is in the context of linguistic research. Because in this area, well, some intuitions are obviously similar because they stemming from pairs and others, but the workings of abduction there are slightly different. That's why I'm not claiming that abduction must be a reasoning, for example. There are probably different forms of cognitive abductive mechanisms, and one of them manifests itself in something that is kind of similar to deduction and induction, but there are also other manifestations as well.